Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 16, 2025, about 5 days ago. This paper introduces monolithic multimodal large language models, which are single models that handle both vision and language, and reports a massive 114-point improvement over EMU3 on the OCR benchmark. The paper is titled Mono-InternVL 1.5 Towards Cheaper and Faster Monolithic Multimodal Large Language Models. And the results for model efficiency are really impressive. It achieves this by embedding special visual experts into the language model, which helps it learn without forgetting its original abilities. This first table gives a great high-level comparison between the original Mono-InternVL and the new 1.5 version, and the results are really striking. The new version uses 58% less training data, which is a huge cost saving. But even with less data, its inference speed, so how fast it generates answers, is 26% faster. What's really impressive is that its performance on benchmarks like VQA Bench, which tests visual question answering, and the general MLLM bench, actually improves slightly. It's a classic case of less is more. So this figure really illustrates the core architectural difference. On the left, you see two approaches. First are modular models, which use a separate visual encoder. That's a dedicated image processor, before sending info to the language model. But the new approach here is monolithic, where visual experts are embedded directly inside the language model, making it a single, unified system. And the radar chart on the right shows the payoff. The dark blue line for Mono-InternVL 1.5 is consistently on the outer edge, showing it performs best across a whole range of benchmarks. Building on that monolithic design, this next diagram breaks down exactly how it works inside. On the left, we see both text and an image of a cat being fed into the model. Now, the key innovation here is a technique called mixture of experts. Think of it like having a team of specialists. Some experts handle text data, and others handle visual data. The first version, Mono-InternVL, uses these text and vision experts, but the improved 1.5 version adds even more visual experts right into the attention mechanism, which is the part of the model that decides what to focus on. This deeper integration is what makes it so much more efficient. Alright, so this diagram really lays out the training recipe, showing how they built these models step by step. They call this process endogenous visual pre-training, which is basically a staged learning approach. The top row is the first model, and you can see it's fed a huge amount of data, starting with almost 1 billion image and text pairs. But the bottom row, for the new 1.5 version, uses a much smarter data-efficient strategy. It uses over 50% less data, but still gets comparable or better results, a direct consequence of that more integrated expert design. Moving to the results, this table compares the new models against a suite of existing ones on general benchmarks. They're split into modular and monolithic types. Now, the number of activated parameters column is really important. It's how much of the model is working to get an answer. You can see the new Mono-InternVL models use just 1.8 billion parameters, far less than the 7 or 8 billion parameter models listed. And despite being smaller, Mono-InternVL 1.5 gets the highest average score among all monolithic models, and it really shines on benchmarks like OCR Bench, scoring a massive 801. And this efficiency isn't just theoretical. This table shows the practical speed benefits. It measures two key things: time to first token, which is how long you wait for a response to begin, and tokens per second, or the model's output speed. The monolithic models are clearly faster than the modular one, but the real kicker is the last row in each group, the 1.5 model with a fused kernel. This is a special software optimization for the GPU. It cuts that initial wait time by over 65% and boosts throughput significantly. So to wrap things up, this work on Mono-InternVL really pushes the boundaries of what monolithic multimodal models can do. Multimodal, of course, just means the model can understand different types of data, like both images and text. The key takeaway is that by cleverly embedding visual experts, the researchers created a model that's not only fast, but also avoids catastrophic forgetting, which is the problem of a model losing its original language skills while learning new visual ones. It's a big step forward for simpler, more deployable AI. That's our roundup for this week. I'm Alex. Thanks for tuning in.